Section 1.4, Polynomials. Learning Objectives. In this section, you will 1. Identify the degree and leading coefficient of polynomials. 2. Add and subtract polynomials. 3. Multiply polynomials. 4. Use FOIL to multiply binomials. 5. Perform operations with polynomials of several variables. Mahi is building a little free library, a small house-shaped book repository, whose front is in the shape of a square topped with a triangle. There will be a rectangular door through which people can take and donate books. Mahi wants to find the area of the front of the library so that they can purchase the correct amount of paint. Using the measurements of the front of the house, shown in Figure 1, we can create an expression that combines several variable terms, allowing us to solve this problem and others like it. Figure 1. First find the area of the square in square feet. A equals s squared equals, open parenthesis, 2x, closed parenthesis, all squared, equals 4x squared. Then find the area of the triangle in square feet. A equals 1 over 2b h. A equals 1 over 2, open parenthesis, 2x, closed parenthesis, multiplied by, open parenthesis, 3 over 2, closed parenthesis. A equals 3 over 2x. Next find the area of the rectangular door in square feet. A equals LW equals x dot 1 equals x. The area of the front of the library can be found by adding the areas of the square and the triangle, and then subtracting the area of the rectangle. When we do this, we get 4x squared plus 3 over 2x minus x feet squared, or 4x squared plus 1 over 2x feet squared. In this section, we will examine expressions such as this one, which combine several variable terms. 1.4.1. Identifying the degree and leading coefficient of polynomials. The formula just found is an example of a polynomial, which is a sum of or difference of terms, each consisting of a variable raised to a non-negative integer power. A number multiplied by a variable raised to an exponent, such as 384 pi, is known as a coefficient. Coefficients can be positive, negative, or zero, and can be whole numbers, decimals, or fractions. Each product, a sub I, x to the power of I, such as 384 pi w, is a term of a polynomial. If a term does not contain a variable, it is called a constant. A polynomial containing only one term, such as 5x to the power of 4, is called a monomial. A polynomial containing two terms, such as 2x minus 9, is called a binomial. A polynomial containing three terms, such as negative 3x squared plus 8x minus 7, is called a trinomial. We can find the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. The term with the highest degree is called the leading term because it is usually written first. The coefficient of the leading term is called the leading coefficient. When a polynomial is written so that the powers are descending, we say that it is in standard form. A sub n, x to the power of n, plus dot, 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 plus a sub 2, x to the power of 2, plus a sub 1, x to the power of 1, plus a sub 0. A sub n, x to the power of n is the leading term. A is the leading coefficient. N is the degree. A. Polynomials. A polynomial is an expression that can be written in the form a sub n, x to the power of n, plus dot, 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 plus a sub 2, x to the power of 2, plus a sub 1, x to the power of 1, plus a sub 0. Each real number a sub I is called a coefficient. The number a sub 0 that is not multiplied by a variable is called a constant. Each product is a term of a polynomial. The highest power of the variable that occurs in the polynomial is called the degree of a polynomial. The leading term is the term with the highest power, and its coefficient is called the leading coefficient. How to? Given a polynomial expression, identify the degree and leading coefficient. 1. Find the highest power of x to determine the degree. 2. Identify the term containing the highest power of x to find the leading term. 3. Identify the coefficient of the leading term. Example 1. Identifying the degree and leading coefficient of a polynomial. For the following polynomials, identify the degree, the leading term, and the leading coefficient. A. 3 plus 2x squared minus 4x cubed. B. 5t to the power of 5 minus 2t to the power of 3 plus 7t. C. 6p minus p to the power of 3 minus 2. Solution. A. The highest power of x is 3, so the degree is 3. The leading term is the term containing that degree, negative 4x cubed. The leading coefficient is the coefficient of that term, negative 4. B. The highest power of t is 5, so the degree is 5. The leading term is the term containing that degree, 5t to the power of 5. The leading coefficient is the coefficient of that term, 5. C. The highest power of p is 3, so the degree is 3. The leading term is the term containing that degree, negative p cubed. The leading coefficient is the coefficient of that term, negative 1. Try it number 1. Identify the degree, leading term, and leading coefficient of the polynomial. 4x squared minus x to the power of 6 plus 2x minus 6. 1.4.2. Adding and subtracting polynomials. We can add and subtract polynomials by combining like terms, which are terms that contain the same variables raised to the same exponents. For example, 5x squared and negative 2x squared are like terms, and can be added to get 3x squared, but 3x and 3x squared are not like terms, and therefore cannot be added. How to? Given multiple polynomials, add or subtract them to simplify the expressions. 1. Combine like terms. 2. Simplify and write in standard form. Example 2. Adding polynomials. Find the sum. Open parenthesis, 12x squared, plus 9x, minus 21, closed parenthesis, plus, open parenthesis, 4x cubed, plus 8x squared, minus 5x, plus 20, closed parenthesis. Solution. 4x cubed, plus, open parenthesis, 12x squared, plus 8x squared, closed parenthesis, plus, open parenthesis, 9x, minus, 5x, closed parenthesis, plus, open parenthesis, negative, 21, plus 20, closed parenthesis. Combine like terms. 4x cubed, plus 20x squared, plus 4x, minus 1. Simplify. Analysis. We can check our answers to these types of problems using a graphing calculator. To check, graph the problem as given along with the simplified answer. The two graphs should be equivalent. Be sure to use the same window to compare the graphs. Using different windows can make the expressions seem equivalent when they are not. Try it number 2. Find the sum. Open parenthesis, 2x cubed, plus 5x squared, minus x, plus 1, closed parenthesis, plus, open parenthesis, 2x squared, minus 3x, minus 4, closed parenthesis. Example 3. Subtracting polynomials. Find the difference. Open parenthesis, 7x to the 4th power, minus x squared, plus 6x, plus 1, closed parenthesis, minus, open parenthesis, 5x cubed, minus 2x squared, plus 3x, plus 2, closed parenthesis. Solution. 7x to the fourth power, minus x squared, plus 6x, plus 1, minus 5x cubed, plus 2x cubed, minus 2. Distribute negative sign. 7x to the fourth power, minus 5x cubed, plus x squared, plus 6x, minus 3x, plus 1, minus 2. Group like terms. 7x to the fourth power, minus 5x cubed, plus x squared, plus 3x, minus 1. Combine, simplify. Analysis. Note that finding the difference between two polynomials is the same as adding the opposite of the second polynomial to the first. Try it number 3. Find the difference. Open parenthesis, negative 7x cubed, minus 7x squared, plus 6x, minus 2, closed parenthesis, minus, open parenthesis, 4x cubed, minus 6x squared, minus x, plus 7, closed parenthesis. 1.4.3. Multiplying polynomials. Multiplying polynomials is a bit more challenging than adding and subtracting polynomials. We must use the distributive property to multiply each term in the first polynomial by each term in the second polynomial. We then combine like terms. We can also use a shortcut called the FOIL method when multiplying binomials. Certain special products follow patterns that we can memorize and use instead of multiplying the polynomials by hand each time. We will look at a variety of ways to multiply polynomials. A. Multiplying polynomials using the distributive property. To multiply a number by a polynomial, we use the distributive property. The number must be distributed to each term of the polynomial. We can distribute the 2 in 2 times, open parenthesis, x, plus 7, closed parenthesis, to obtain the equivalent expression 2x, plus 14. When multiplying polynomials, the distributive property allows us to multiply each term of the first polynomial by each term of the second. We then add the products together and combine like terms to simplify. How to? Given the multiplication of two polynomials, use the distributive property to simplify the expression. 1. Multiply each term of the first polynomial by each term of the second. 2. Combine like terms. 3. Simplify. Example 4. Multiplying polynomials using the distributive property. Find the product. Open parenthesis, 2x, plus 1, closed parenthesis, multiplied by, open parenthesis, 3x squared, minus, x, plus 4, closed parenthesis. Solution. 2x, open parenthesis, 3x squared, minus, x, plus 4, closed parenthesis, plus 1, open parenthesis, 3x squared, minus, x, plus 4, closed parenthesis. Use the distributive property. Open parenthesis, 6x cubed, minus, 2x squared, plus 8x, closed parenthesis, plus, open parenthesis, 3x squared, minus, x, plus 4, closed parenthesis. Multiply. 6x cubed, plus, open parenthesis, negative 2x squared, plus 3x squared, closed parenthesis, plus, open parenthesis, 8x, minus, x, closed parenthesis, plus 4. Combine like terms. 6x cubed, plus x squared, plus 7x, plus 4. Simplify. Analysis. We can use a table to keep track of our work, as shown in Table 1. Write one polynomial across the top and the other down the side. For each box in the table, multiply the term for that row by the term for that column. Then add all of the terms together, combine like terms, and simplify. Table 1. 3x squared, minus, x, plus 4. 2x, 6x cubed, minus, 2x squared, 8x. Plus 1, 3x squared, minus, x, plus 4. Try it number 4. Find the product. Open parenthesis, 3x plus 2, closed parenthesis, multiplied by, open parenthesis, x cubed, minus 4x squared, plus 7, closed parenthesis. B. Using FOIL to multiply binomials. A shortcut called FOIL is sometimes used to find the product of two binomials. It is called FOIL because we multiply the first terms, the outer terms, the inner terms, and then the last terms of each binomial. Open parenthesis, a, x, plus b, closed parenthesis, multiplied by, open parenthesis, c, x, plus d, closed parenthesis, equals, a, c, x squared, plus a, d, x, plus b, c, x, plus b, d. Open parenthesis, a, x, plus b, closed parenthesis, multiplied by, open parenthesis, c, x, plus d, closed parenthesis. A, x, and c, x are the first terms. A, x, and d are the outer terms. B, and c, x are the inner terms. B, and d are the last terms. The FOIL method arises out of the distributive property. We are simply multiplying each term of the first binomial by each term of the second binomial, and then combining like terms. How to? Given two binomials, use FOIL to simplify the expression. 1. Multiply the first terms of each binomial. 2. Multiply the outer terms of the binomials. 3. Multiply the inner terms of the binomials. 4. Multiply the last terms of each binomial. 5. Add the products. 6. Combine like terms and simplify. Example 5. Using FOIL to multiply binomials. Use FOIL to find the product. Open parenthesis, 2x, minus, 18, closed parenthesis, multiplied by, open parenthesis, 3x, plus 3, closed parenthesis. Solution. Find the product of the first terms. 2x, dot, 3x, equals, 6x squared. Find the product of the outer terms. 2x, dot, 3, equals, 6x. Find the product of the inner terms. Negative 18, dot, 3x, equals, negative 54x. Find the product of the last terms. Negative 18, dot, 3, equals, negative 54. 6x squared, plus 6x, minus, 54x, minus, 54. Add the products. Equals 6x squared, plus, open parenthesis, 6x, minus, 54x, closed parenthesis, minus, 54. Combine like terms. Equals 6x squared, minus, 48x, minus, 54. Simplify. Try it number 5. Use FOIL to find the product. Open parenthesis, x, plus 7, closed parenthesis, multiplied by, open parenthesis, 3x, minus, 5, closed parenthesis.